In this video, we'll demonstrate a procedure for constructing confidence intervals using SPSS. We begin by noting that confidence intervals are constructed for variables measured at the interval scale level. In this voter file, there are three variables measured at the interval scale level: age, education, and income. For this example, we'll concentrate on age and construct 90, 95, and 99% confidence intervals for the mean age. We begin with the Analyze Descriptive Statistics Explore command sequence. On the Explore window, we take the variable age, we move it from the left panel to the dependents list panel. We now tell SPSS which statistics to display in the output. Now, notice that by default, SPSS will construct a 95% confidence interval for the mean. I'm going to start with a 90% confidence interval, so I'm going to click in this field and I'm going to change that 95 to 90. I'm going to click Continue. Now, in the output, all I want to display are the statistics. We now click OK, and here is the output. For this example, the mean age of the respondents in this sample is 47.91 years. This number is the center of a confidence interval. That is, it is the point around which the confidence interval is constructed. Since we have a 90% confidence interval, the lower limit or lower bound of the interval is 47.21 years. The upper bound is 48.61 years. We use confidence intervals to estimate the population parameter based on the sample statistic. We may not know exactly what the mean age of the whole population is, but there is a 90% chance that that mean age is between 47.21 years and 48.61 years. Notice that the difference between the upper and lower bounds of this confidence interval is 1.4 years. Please bear that number in mind as we construct the next confidence interval. Again, on the Analyze Descriptive Statistics Explore command sequence, we see that age is already in the dependent list panel. So let's again click on Statistics. Now we want the 95% confidence interval. So let's change that 90 to 95. Let's click Continue. And again, we're going to display only the statistics. We click OK, and here is the new output. Again, the mean age remains the same. It's the same sample of 1,500 respondents. Now we have a 95% confidence interval for the mean. In this confidence interval, the lower bound is 47.07 years. The upper bound is 48.74 years. Notice that the difference between the upper and lower bounds here is greater than it was in the previous example. Here, the difference is 1.67 years. This is what we mean when we say that the the 95% confidence interval is slightly less precise as an estimate of the population mean than the 90%, because the interval itself is wider than the 90% confidence interval. But on the other hand, we can now say that the probability that the true population mean age is between 47.07 years and 48.74 years is 0.95. We have more confidence in this confidence interval because it has a higher probability. Finally, let's do a 99% confidence interval. Analyze, descriptive statistics, explore, age, statistics, change the 95 to 99, continue, and OK. This confidence interval is the widest of the three that we have produced. Here, the difference between the upper bound of 49.01 years and lower bound of 46.81 years is 2.2 years. This is the least precise of the estimates of the true population mean age because it is the widest. However, it is also the confidence interval with the highest probability. There is a 99% chance that the true population mean age lies between 46.81 years and 49.01 years. From this example, you should see that the level of precision and the level of confidence are inversely related. That is, as the level of confidence goes up, the level of precision goes down. The 90% confidence interval was the narrowest, hence the most accurate or precise estimate of the true population mean age. However, we only had a 90% probability. This 99% confidence interval is the widest. It's the least precise of our three estimates, but it is the estimate in which we have the highest confidence because the probability is 99%. We should also note one other concluding comment here. It's possible, as I'm going to show here, to construct confidence intervals of any level. 90, 95, and 99% confidence intervals are commonly used, with 95% being the most commonly used estimate for social science. However, there's nothing that says we can't do something like a 10% confidence interval. Watch what happens here. Notice here how precise the estimate is. There's only 0.1 years difference between the upper bound of this confidence interval and the lower bound of the interval. However, the probability that the true mean age of the population lies within this interval is only 10%. So there's reason why we choose confidence intervals of 90, 95, and 99%, and most often 95%, especially in criminal justice and sociology. This concludes this video on confidence intervals.